The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, good morning, wherever you are in the country. It's Mark from SolidCAM. We'll be starting our SolidCAM Live for today. It's a half-hour free training session. With me, as always, we have Kevin Rankel. Hey, Kevin, how you doing?
Doing good. Hey, everyone. Thanks for joining.
Perfect. Okay, so little note real quick. We've seen some issues online today with GoToMeeting, with the phone line, so you might not be able to hear me for a bit. You can use the question panel to let me know if you can hear me or not. I just want to make sure that that we don't lose audio. But that, just as an advisor, that seems to have been happening today, so just in case. Now, today, we will address a question that we got from someone in attendance, Frank. Frank sent me a question regarding if he takes a turned stock and now he needs to do a milling toolpath or a milling part on that stock, how does he set that up? So you can see on my part here, I have the final part. It's just a piece of a coupling. And the stock is the transparent solid there. And it's basically just the turn stock there, maybe a little bit of an outside contour, and then just the center hole. So how that was set up is these are actually two separate solids inside this design model. So if we take a look at my design model, I have two solids. I have the original part that eventually I select as my target, and then I have the stock, which is basically just another 3D model as part of that part file that is a separate solid, and I selected that as my stock. Now you can do it that way, or you can use configurations. You can use a separate solid completely. Let's say when you first bring in your target inside SolidCAM, once you get inside SolidCAM, you can go to your assembly and insert components and insert that other 3D model as well. But basically the idea here is that you have something that represents the turn stock as a 3D model. You'll come into your stock definition, set it to 3D model, and select that solid. And that's basically it. So it doesn't matter if it's a turn stock or a casting, forging, a 3D model. Whatever 3D model itself you bring in, you can assign as the stock. And there are some times where even if you don't have a 3D model that represents the final, the stock that will become the final part, but you do obviously have your design model, sometimes you can even select that. And at minimum, you can check for your collisions in your Solid Verify and your machine sims, because at least you have something to check against. And if that represents the final part, any gouges of that final part, even if it's set to stock or target, still count as a gouge. So you can still troubleshoot your part that way. But if you have any 3D model, you can assign that as your stock. Now, while we're on this screen, let me see if I can just get rid of that highlight there. Well, either way, let's see if I can undo that. All right. Now, if you go into your stock definition, let me just unselect the solid here so it unhighlights it. So let's say we don't have that 3D model that represents the stock, but I do have the final part, and the final part is possibly a casting. So obviously with a casting, there's probably going to be additional material on some of these extra faces, anything that I'm going to kind of machine to precision or something like that. Let's say this was the casting of this coupling, and I just need to do this hole in here. Well, what you can do is you can actually select that final part as your stock, and then add an offset to it. So let's say we add, what would be a typical offset, do you think, Kevin?
Let's do 0.125, like for a casting.
125, all right. So what that basically does is it offsets on all faces, and let's let that calculate for a second there, from that target model. It's going to add just an additional amount of material on all the faces. And if we take a look at that in show, let's see when that window pops up. If it'll pop up.
You may have to hit the green check mark and then do a show. Now go ahead and do the show. Is it popping up on a different screen?
It's not on the other screen.
Maybe let's just do a show on model.
All right, we'll show on model, and
I think it's not grabbing it.
Well, basically, it works very similar to what you would probably see as an offset in like your toolpath. All the faces, it will have an offset of a certain amount, and then that is understood to be the stock. So you'll actually be able to machine, let's say, looks like it went through. So let me just go into the Solid Verify. Maybe it'll show up. 125 might have been too much. Let's go back in there. And let's make it just maybe 50,000, just so we can get something visual. No, all right. Yep, good times in SolidCAM Live. Okay, so what happens is you choose the solid and then it adds the offset faces to it. So in this case, if I wanted to just remachine that hole to bring it to size, then it would actually understand that there's about 50,000 material there, and it would show in the Solid Verify that that material is being removed. So what you're really just doing here is you are simulating the idea that on all faces, there's additional material, and you're doing that just off of the one solid. If we go to the stock definition again, and let's just set that back to 0. And I'll just unselect that. The other options in here are, in this case, for instance, this one, we could do a revolve around boundary, revolve around Z. So when you select that, you're basically getting it back to that same chain list selection screen. And if we take a look at my little profile there, should be able to grab that. Let's just do we do constant Z? There it is. So I have a chain. So we take a look at that. That also will generate a revolved boundary around Z. Now this is more for mill turn, where you actually have a rotary that you can revolve around, but this gives you another quick stock. So rather than getting a 3D model, if you wanted to, you could just grab a profile or draw in a profile and then just revolve that around Z to get your turn stock. And of course, there is always cylinder. Now, cylinder really just works when you have your Z-axis dead center of your part. Again, more for mill turn and turning, but when it revolves around Z, it actually is just taking it's just giving you a definition here. Let me just grab my solid here. So that's my target that I selected, and it puts either an incremental amount of material on the outside, so in this case, relative to model. I have it set to 50 thou on the front face, 1 inch on the back face, and then radially I have 100 thou, and that's what that cylinder represents there. That's basically just a very basic cylinder, OD, ID, and length, and it revolves it around Z. If I do absolute coordinates, it's exactly the same, except this time it actually is taking these dimensions. So for whatever reason, I guess maybe this is from a metric install, externally I have a 50-inch diameter, and then I also have, I guess, 100-inch long cylinder there. But you can actually you shrink this down to your part. So you just click on Take Model Dimensions, and you can see that is the minimum size of the stock needed to turn this thing. So basically front face, back face, and then the exact diameter. And then from there, you can play with these values to give it more material. But these are now absolute values. And again, this only really works for when you have the Z-axis dead center of your part. You can do the cylinder definition in milling as well, but that's only when it's top dead center, not usually when you have it on the corner. Otherwise, what you'll get is you'll get a cylinder that has a radius of basically the entire part. So if you had, let's say, top corner of model stock, you'd have a cylinder that has that entire radius there. Now, let's say you don't have a 3D model inside SolidWorks, or you don't have a IGES file, step file that you've translated into SolidWorks to represent your stock solid. You could use the STL option. The STL option is a little more difficult to work with, but you can use it. And basically what that is every time you define your stock, every time you do a machine stock inside of Solid Verify, that generates an STL. You can take that STL and bring it into another CAM part file. So in the case of what we're doing here, let's say we programmed this part originally in SolidCAM turning, SolidCAM mill turn, and then we saved that STL and then reloaded it here in the milling part file. you can use the STL file to represent the stock just like we did here. And that is very useful for when you have a lot more of a complex stock. Maybe not just a turn stock, but maybe a turn stock that has a lot of different radii in it, or it's a unique shape that you can't easily recreate inside SolidWorks with either a sketch or a 3D model. So when there's more complexity to your updated stock that you're trying to retain, the STL model is an easier option. But that's the only time I'll say STL is easy, because STLs are very hard to work with because of just the definitions in the background. Hard to work with in terms of the extra steps required. It's not just a matter of just loading a SolidWorks model and selecting it. With STL, it's a matter of what coordinate system it was saved under. Sometimes you have to check your settings to make sure that you imported it in the proper units, because STLs are notorious for, let's say you save it as 1 inch by 1 inch by 1 inch, and then when you load it into SolidCAM or SolidWorks, whatever you're doing with it, it actually ends up being 1 meter by 1 meter by 1 meter, because that number is the same, but the units that you imported it in could be different. So sometimes you got to deal with that. But again, just an additional step just to confirm that. But in terms of stock definition, all you're really doing is bringing in whatever represents the raw material that you're about to machine to become the target solid. So I want to see what the question is there. So is the revolve around Z available on the mill only? No, I believe it's mill turn and turning. I don't know. Kevin, do you think it's, yeah, okay. So anytime you're in the mill turn module, you should have that ability to do a revolve around Z.
And anytime that you guys are doing a turning project, it's a little off subject, but if you guys are doing a turning only, you should be using, instead of saying new turning, you should be using mill turn, even though that you're only going to be doing turning. And then that's just because there's more features with the mill turn, just like what we're showing that revolve around Z, but on top of adding additional coordinate systems and stuff like that. So turning and mill turn are going to be the same for you. So if you guys want, you can, like Mark, can go to his customized menu and just get rid of turning in there. Because even if you guys only have, like I said, a lathe, you should still be picking mill turn.
Absolutely. And you'll notice that that customized menu is pretty much, I think we introduced that very recently, where it's pretty much at the bottom of every one of our menus now. So if you tend to just skip over a lot of this stuff, or let's say in your toolpath list over here, if you don't even have some of these, you can go to customize, and then we just bring the window over. I can't bring the window over, but you can uncheck the box next to the names of all the toolpaths that you don't have, and then that way your list gets really shrunk. Okay, so any questions on the stock definition options?
Looks like Frank's was the only one so far.
Oh, okay, great. Perfect, okay. So the same sort of thing can be done with a single solid, especially a part that is basically turned and then becoming a milled part. Let's say, for instance, let's go into my design model. And I'm going to hide that stock. So let's say I brought in only a target solid like this. Now, what you can do to really simplify your design, really simplify your programming, is add what's called a configuration. Now, I've done a couple of videos on this, but if we're on the topic of stock definition with 3D model, this is actually something that I find very useful, and a lot of people probably don't know how to do this, but it's actually really simple. Let me get out of the part here. And I'm going to get out of the CAM part as well. And let's actually go to the original part, because again, like always, if you're going to make a change to your SolidWorks model or your design model, you want to do it inside SolidWorks, not inside SolidCAM. That way, everything is from the beginning to end. The associativity goes from SolidWorks into SolidCAM. You want to stay that way. Again, we can check out all my little files here. We're going to go into my mill turn. And let me get my little preview window on. We've got that one, and there it is. Okay, so let's open that guy up. This is one of my older files. I used this in one of our SolidCAM videos. I forget for which one, but basically what we have here is a single SolidWorks part file with two solids in there. And that's not necessary to do what we're talking about. I don't necessarily have to have a separate solid, a separate part file in this menu to get my turn stock. It actually might even be a little easier and might even be a little easier to understand what we're about to do here. So if this part is a turn part and then with some milling features, what I can do is I can go to this tab here, Configuration Manager. I can right click and add a configuration. Let's call this configuration stock. So in this one, I'm actually going to hide a lot of these features. I just want to get the thing that looks like the turn stock. So let's start by just rolling this back. So we've got our base, got our chamfer, we've got that guy. That's fine there. A little bit of fillet. I've got the cut. I'm going to roll all the way forward here. I thought it was a little easier than that, but let's say we get rid of this cut right here. So I'm going to suppress that. And suppressing that suppresses all these other guys because these were related. So what we have here is what looks like my turn stock. And again, it's a single solid that I'm dealing with. The use of configurations allows me to do that. I go to the feature tree, suppress something, and then when I go back to the configuration manager, I can just return to the default, which has all those features still turned on. Okay? So configuration allows you to make two different versions of the same part. Certain features suppressed, certain features turned on in certain cases, but I actually have one part file that I'm dealing with that has two versions of it. Let me toggle between those again. So if I double click on stock, it becomes a stock. If I double click on default, I can relabel this if I like, but basically this is with all the features turned on. So now in one part file, I have the milled version and the turn version. How that helps us inside SolidCAM is like this. Let's close out of this part file. Let's go back to that same CAM part file. It's going to recognize the change eventually. You will see that it updates itself. Okay. And what I want to do is I want to go into my settings, make a change to my settings. I'm going to get it to synchronize on demand. And I'm going to get it to associate the geometry with the parent configuration. Parent configuration means when I first select the stock, when I first select the target, it's locked into those versions of the file, those configurations of that file. So now with that done, I'll go into my stock definition. What we're looking at on screen right now is, actually, I wonder if it's still associated or not, because it really should be showing up here. Let's get out of here. And I'm just going to change model reference to that part file. There it is, change model, yes. So now that configuration should pop up inside of my window. Once it's done updating itself. I can double check that by saying there it is, perfect. Okay, so now that there's a configuration associated with my design model, when I go into stock, I'll unselect this. And now you can see there's a configuration menu here as well. So instead of choosing my default solid, the one that represents the final part, the milled part, for my stock, I want the stock configuration, like that. Now I can click on that solid. When I click the green check mark, that version of that single part file represents my stock. When I go into target, I'll basically do the opposite. Let's go to target, unselect the target. We'll switch this to the default configuration. So you can see there it's on screen. Select that. Click the green check mark. So even though on screen we're looking at the default, the target configuration, if I show the stock, it does that. Okay, let's go back in here and see what's going on. I have this turned on. Turn that off. So it's a lot of thinking, but basically it's because I've changed a lot of the definitions. We'll get it to recalculate. And let's do a CAM part cleanup. We got too much going on here. Interesting, okay.
And that CAM part cleanup, guys, is real nice because as you keep building on top of your model, adding geometries, adding stocks, that is still all saved internally for everyone. And by going in there, and you can actually reduce your file size. Maybe you're running low on size, or if you want to email a file out, you guys can go in there and click on the cleanup CAM part. You can select everything to remove anything that's unused, and it will pretty much take your file size and dramatically reduce the size of that for you.
Okay, so I'm just going to look at my stock definition here. I just set it to cylinder just to see if I can clean things up a little bit. Not sure why it doesn't want to show the stock. There it is. Okay, so now that we have a cylinder definition, that should be a little cleaner. Let's go into stock. Change this to 3D model. Make sure that it's set to my stock configuration. Offset is set to 0. We'll grab that. And because it's a mill turn module, it wants to revolve that, give me that profile there, and now I should be able to check that box. And you can see it's very similar to what we had before. The solid represents the stock. So I'll turn that off. It shows it as the stock. I'm just going to set that back to default. But if we show the stock again, it still shows it as that guy right there. Now, I actually probably made the mistake. In the configuration, I didn't suppress that cutout on the other side. So that is also a good example of what happens there. This is not a revolved part. This is a literal solid that was represented by that configuration. So I probably just have to go back and suppress that feature that cut that bit out there. But actually, no, that's my mistake. It is the updated stock. There it is. So the idea is configurations. Inside SolidWorks, you have the ability to make multiple versions of your same part file. You just have to suppress different features. So how that helps you when you have a turned part that becomes a mill part is just suppress the milled features, and then you'll get something that looks like your turned part. Hopefully that makes sense.
That's easier. Yep.
I would say from the part that you described, Frank, it probably would be easier because in your SolidWorks part, you can suppress whatever slots, whatever pockets, whatever flats you have, and then you have what looks like a turned part. It doesn't necessarily have to be all kinds of features like I had here, where after a certain point, it's all mill features. It could literally be the fillet, the chamfer that you're adding, any holes you're drilling out, anything that you have peppered throughout your feature tree. You can actually suppress them individually and then only leave behind revolved features. Anything that you did a revolve or an extrusion of, you can suppress anything in there and then just save that as a type of configuration. Even if you have a part, let's say you have a part that's extra long and you need to turn certain features of it before you can go to the next stage. You have the ability to set as many configurations as you like. So let's say you have to face and center the front of a very long shaft. That could be one configuration. And then a second configuration represents the second stage where you do the extra long turning between centers. And then now that shaft has some keyways in it or something. You can have a third configuration where it's all of that plus the extrusions, the pockets that represent the keyways and the flats and all the milled features. So configurations are a really great way to really shortcut on the design side of things, make families of parts or versions of parts, but then that also helps you on the programming side of things because now you don't have to keep track of different files. It is also associative because it's the same file. So if a design change is done to, let's say, the outside diameters of this turned stock, well, it's the same part file. So all that associativity is still there, and it updates your version of the stock as well as your version of the target.
And one thing to remember too is Mark only created one configuration. You guys can have as many configurations as you guys would like. So you could pile on, you know, maybe one configuration is just your stock. Maybe one configuration would be the holes missing. Another configuration would be other parts. So you're not limited just to you know, one configuration in there. You can have multiples in there.
And that also holds for assemblies as well. It gets a little more complex on the assembly side, but you have the ability to do configurations of any type of SolidWorks file. So if you had a setup where, like I said, maybe that example of the you faced it and turned it, faced it and centered it, that could be one setup. How it sits in your custom-made jaws, custom chuck, and then you do a configuration where you suppress those jaws, and now you have another set of jaws between centers. Or whatever, let's say you have a vise and you have different sizes of the vise for different sizes of stock, different configurations. Inside SolidWorks, there's a lot of ability to change the part, change configurations, and there's also something related to configurations called display states, and that's this guy down here. The difference between the top and the bottom is in configurations, I'm suppressing features. In display states, I'm just hiding and showing stuff. And this is a little more useful for fixtures, because if you saw one of our videos on our YouTube channel, I have a fixture on side 1 or holding the part on side 1, and then a fixture holding the part on side 2. Everything's on screen, nothing is suppressed, because as soon as you suppress something, it's not seen by the software, and that can really disrupt some of your definitions if you suppress too often. But if you want to just hide it from your view, then what you can do is you can hide it using display states. And it works the same way. You can just right click and say add display state. And then what happens is you can hide the vices from side 1 to only show side 2, or hide the vices from side 2 and only show side 1. And then when you toggle between your display states, you can actually just hide and show an entire assembly in a single click. Okay, so there's another question here. So can a program be created and distributed to these multiple configurations? So much is being commented on, but I can't replicate without an example. Can a program be created and distributed to these multiple configurations? If I understand your question, yes, because the way configurations works is if you say had one part that had multiple configurations of a family of parts, with these settings here, let me go into the settings, you can actually set your settings so that it associates with the current configuration. So if I programmed, let's say, a family of parts, a standard length, an extra long length, and a super long length, and the only difference between the family of parts is the length of, let's say, the shaft. Let's say we've got our part here and the length of this part right here. If I set up a part that has configurations, and the only change I make is just the length of the part, when I toggle between the configurations, the geometry will update to show that difference in length, but the toolpath is still associated with those same contours. So what you can do is you can actually regenerate your code, and it'll actually associate itself with the new version of the geometry, and then show an extra long, a super long, or a standard long toolpath. So it's just a matter of the variability of the geometry. Okay, if I understand that last comment then, Brad, I mean, I can send you this part file if you'd like, if that's what you mean by distributed to customer, for example. A lot of these examples can be found on our website, or if you find a file, not just this one, but any file in any of our videos, then all you got to do is just send us an email and you can request it. But yes, absolutely, I can send you this file. There's actually probably a better file that shows configurations, but this one is very simple, so I can send you this one as well if you like. Let's see, so we are at the half-hour mark. If you have any other questions, I'm going to give you my email in the chat section. This is a half-hour free training session that we're doing every day at 2 p.m. Eastern Time up until, I guess, the end of this week. If there's more of a demand, just let us know. Email me or Kevin, letting us know that you'd like this to continue, and then we can continue if you like. Any questions, go ahead and email me. I think that's it. Yeah. So, like I said, any questions? We're going to be doing this for the rest of the week, 2 p.m. Eastern Time. If not, I hope you guys are well, you're safe, your families are safe. We will talk to you tomorrow.
All right, thanks everyone.